Okay, let's unpack this. We're diving deep today into something that blends centuries of expertise with cutting-edge tech. How the UK Hydrographic Office, the legendary UKHO, the folks charting the seas, keeping mariners safe, and supporting defense, is thinking about large language models.
Right. They've got this incredible history and just an immense amount of data to manage.
Exactly. And when most people hear LLMs, they might think chatbots, maybe creative writing.
Yeah, the usual suspects.
Mhm.
But the source material for this deep dive, it's actually a strategic blueprint. It's a really thoughtful, pragmatic look at how a vital public service organization plans to adopt this technology specifically within the unique context of the UKHO.
And that's our mission for this deep dive. We're going to pull out the core insights from this document. We want to get at the why, the what, and the how of the UKHO's journey with LLMs.
Think of it as a shortcut, maybe. A shortcut to understanding a really fascinating real-world application of this technology. And a critical public service context, too.
Definitely. And honestly, there are some surprising nuggets in here, like how LLMs could potentially help analyze really old historical data or, even support military training. It's quite broad.
What's genuinely insightful here, I think, is that the UKHO's drive for innovation isn't just about hopping on a tech trend. It's not novelty for novelty's sake.
No, it seems deeply rooted in their strategic needs, their
Yeah.
core mission.
Exactly. Which brings us to the why.
Right, the why. The document lays out several key drivers for even looking at LLMs in the first place. There's enhancing national security, obviously a big one, supporting defense obligations.
Critical.
Then there's driving economic growth, making their high-quality data more accessible, more useful.
Which is huge given the value of maritime data.
Absolutely. Achieving data-driven efficiencies is massive because, like you said, they handle absolutely enormous volumes of complex maritime data.
The data deluge problem.
Yeah, and supporting sustainability goals like decarbonization through better voyage optimization. That's another key driver.
And then there's the sort of broader context.
Right, the push for digital transformation across government services, plus strengthening international collaboration, which is, vital for a global organization like the UKHO.
And if we connect this to the bigger picture, any LLM adoption absolutely must directly support those core UKHO pillars: maritime safety, national security, and environmental sustainability.
Yeah, the technology isn't the goal in itself.
No, it's a tool serving a critical purpose. Technology serving purpose.
And it goes down to the operational level, too, doesn't it? I mean, LLMs are also seen as a way to enhance day-to-day efficiency.
Definitely. Automating tasks, finding ways to optimize costs, fostering innovation in the products and services they offer.
And even strengthening those international partnerships, maybe through more efficient translation or information sharing.
Which raises an important question. Are they just starting from scratch with this? Just diving into LLMs cold?
Good question. And the document makes it clear they are not. They're building directly on insights gained from earlier AI trials they've already conducted at the UKHO.
Ah, okay. So there's history there.
Yes, they've been experimenting for a while now. Things like trying out automated methods for cleaning bathymetric data underwater depth data.
Right, which is notoriously complex.
And using generative AI tools as part of their Admiralty Virtual Ports initiative to create 3D port models using tools like CADIM, for instance.
Okay, so visualization too.
Yeah. They've applied machine learning for things like detecting coastlines from satellite imagery, and they've already been doing AI-assisted text analysis for things like processing maritime safety alerts, monitoring media, or, doing research and horizon scanning using tools we're all becoming familiar with, like Copilot and Gemini.
So they've already kicked the tires on some of this tech.
Seems so. They've even looked at AI-powered assistance for their software developers.
And these earlier trials, presumably, provide crucial practical learning. Lessons learned.
Exactly. They've learned lessons about data readiness, how prepared their data actually is for AI, the skills they need to build within the organization, and crucially, where AI can genuinely deliver value before committing to, large-scale LLM deployments.
It's a smart, iterative approach. Learn as you go.
Okay, so we understand the strategic why. Given those drivers, the natural next question is, what does this actually look like in practice? What can LLMs actually help the UKHO do? Let's move to the what.
Yeah, the high-impact use cases the document identifies.
Yeah.
And it structures this really well. Let's start with the heart of their work, core hydrographic operations.
Okay.
The sheer volume of data coming in from modern sensors, that data deluge we mentioned, it's a major challenge. LLMs could offer advanced automation for bathymetric data cleaning, validation, and spotting anomalies.
How exactly would an LLM help with something as technical as cleaning underwater depth data? I mean, it's mostly numbers, right?
Well, yes and no. It augments their existing methods. Hydrographic data isn't just numbers. It comes with survey logs, reports, textual metadata. An LLM could process all that text to bring contextual understanding.
Ah, okay. So it reads the notes.
Kind of. Maybe spotting notes about unusual seabed types or flags a surveyor raised in a report, and using that context to help validate automated cleaning suggestions or improve the quality of the QA reports. It's about blending the numerical and the textual understanding.
Okay, that makes sense. And this is where it gets really interesting, thinking about LLMs enhancing nautical chart production itself. What specifically could they assist with there?
This is fascinating because chart production involves interpreting complex specifications and making detailed decisions, like generalization, deciding how to represent features clearly at different scales. That's a real skill.
Very human-centric currently.
Exactly. LLMs could potentially assist in interpreting those complex specifications, maybe drafting the initial text for notes that need to go on a chart, or even generating reports explaining why certain generalization decisions were made, documenting the rationale.
And quality assurance.
Crucially, they could significantly enhance QA by reviewing all the textual elements on charts. The notes, warnings, legends, checking them for consistency, compliance with standards. That's often a manual, painstaking process.
I can imagine.
They could also analyze textual feedback coming from mariners to spot recurring issues that might indicate a chart anomaly or an area needing attention.
And suggesting automated generalization.
The document mentions that as a possibility, potentially suggesting automated generalization, but it heavily emphasizes that expert human oversight is absolutely essential. These are tools to assist, not replace, the hydrographer or cartographer.
Right. Human oversight is critical, especially for safety of life at sea. You can't automate that final check.
Absolutely not.
And that generative AI work for 3D port, modeling the Admiralty Virtual Ports Initiative.
Yep.
You mentioned Kadim.
Yes, so generative AI helps create the 3D visual models. LLMs can then augment this. How? By processing textual information, historical context about a port, environmental sensitivities of an area, specific operational details, and layering that knowledge onto the 3D model.
So enriching the visual with text-based context.
Exactly. But the real power here is enabling natural language querying. Imagine a port planner, or maybe a ship's master, being able to ask the 3D model system in plain English, something like, show me all charted depths less than 12 meters near this specific terminal, based on the latest survey data.
Wow.
An LLM could interpret that complex query and highlight the relevant areas in the model. It's a whole new way to interact with the data.
That really does provide a completely new way to interact. And extending the machine learning work on automated coastline detection, how does an LLM add to that?
Right, so the ML models detect the physical coastline from imagery. LLMs can process associated textual data, like old survey notes mentioning erosion rates or reports on coastal changes.
And use that text to, confirm the image analysis?
To help validate or enrich those automated detections, essentially. They support the QA process by cross-referencing the detected feature with any available text descriptions or historical context. It adds another layer of confidence.
Okay. Stepping beyond core charting, the source looks at enhancing maritime safety, security, and environmental protection. How do LLMs apply in these really high-stakes areas?
Yeah, this is critical stuff. A vital application is intelligent processing and analysis of maritime safety information, or MSI, and associated alerts. Getting timely and accurate MSI out is paramount for safety of life at sea.
Absolutely. Seconds can count.
LLMs could help by quickly summarizing alerts, extracting key details like the exact hazard type, precise location, effective dates, classifying the urgency, maybe cross-referencing with other relevant data like chart information.
And maybe answering questions about them.
Yes, answering natural language queries from users, asking about hazards in a specific area. They could potentially even enable personalized information delivery based on a vessel's type or planned route.
That sounds really powerful. And for defense and national security, including supporting things like mine countermeasures, the stakes are incredibly high there.
Absolutely critical applications here, yes.
Yeah.
LLMs could assist in analyzing diverse textual intelligence feeds, reports, intercepts, that kind of thing. They could generate initial drafts of reports that inform planning briefs.
So helping analysts get started.
Potentially. supporting military simulations and training by helping create realistic scenarios with dynamic textual elements, and potentially interpreting textual data coming in from autonomous platforms like underwater or surface vessels, EUVs, or USVs.
But there's a flip side there, isn't there? With security.
It's worth pausing to note the dual nature here. LLMs can be incredibly useful for detecting cyber threats aimed at maritime infrastructure, but the same technology could potentially be used by adversaries to create those threats.
Right, so robust security measures are baked in from the start.
They have to be. It underscores the need for very strong countermeasures and security by design.
So they can help enhance maritime domain awareness, spotting suspicious activity out at sea.
Yes, precisely. Maritime domain awareness, or MDA, involves understanding everything happening in the maritime space.
Yeah.
It's a huge puzzle. LLMs can process incredibly diverse data sets, intelligence reports, global news feeds, social media, even analyzing textual fields embedded within AI data from vessels.
AIS, the Automatic Identification System.
Yeah. Ships transmit data, some of which is text like destination, cargo type. LLMs could analyze that text for anomalies. They could help identify suspicious patterns, like irregular vessel behavior based on deviations from normal textual descriptions or destinations.
So flagging things that look out of place.
Exactly, supporting real-time risk assessment by synthesizing these disparate inputs and contributing to dynamic threat assessments by compiling and summarizing relevant information for analysts.
And finally in this section, how about environmental monitoring and sustainable marine management? That was another driver.
LLMs have a role here too. They can analyze vast amounts of scientific literature, environmental regulations, and data sets to extract key environmental insights relevant to the marine domain, helping researchers or planners make sense of huge volumes of text.
Like for marine spatial planning?
Exactly. They can advance marine spatial planning by synthesizing diverse textual inputs, like survey findings, environmental impact studies, public consultation feedback, helping to build a richer picture.
And supporting the UKHO's own green goals.
Yes, supporting the UKHO's own decarbonization goals, for example, by assisting with the complex analysis of data needed for voyage optimization and route planning to minimize emissions. It's about using data smartly for sustainability.
Okay, let's shift gears again to something that seems like a very natural fit for LLMs, especially given the UKHO's long history and those incredible archives they must have. Optimizing internal processes and knowledge management?
Yeah, Intelligent Knowledge Management, or IKM. This is a potentially huge GE opportunity. The UKO possesses truly vast archives. We're talking centuries of survey logs, historical reports, old charts, maybe with handwritten notes. An absolute treasure trove.
But probably hard to search or use effectively.
Historically, yes. LLMs can unlock this data through natural language querying. Imagine being able to ask a system in plain English something like, tell me about seabed changes recorded in Portsmouth Harbor between 1950 and 1960, based on historical survey notes.
And getting a synthesized answer, not just a list of documents.
Exactly, getting a synthesized answer. They enable contextual search, summarization of lengthy reports, extracting key details from unstructured text, even assisting with onboarding new staff by providing quick access to institutional knowledge.
That onboarding point is interesting, like an internal expert system.
Sort of. And they could potentially even identify anomalies in historical textual data that might indicate past survey issues or unusual environmental events recorded long ago. Finding needles in haystacks.
Unlocking that historical data sounds incredible, but surely preparing it must be a monumental task. All those old paper records.
It's a significant challenge, absolutely. The document acknowledges this. Data preparation, digitization of physical records, ensuring quality across diverse formats and ages, and maintaining stringent security for these sensitive archives. These are critical implementation hurdles that need careful planning and resources.
Okay. What about the people actually building the systems? The document mentions AI-powered software development assistants. Is that like GitHub Copilot?
Yes, similar tools, aligning with trials happening across the UK government. These assistants are tools to empower the UKHO's own technologists, boosting efficiency.
Guess so.
They can help with things like generating boilerplate code, improving documentation quality and consistency, assisting with debugging complex issues, and potentially helping to reduce technical debt in legacy systems by understanding and suggesting refactors.
So making the tech teams more productive.
It's essentially yes. But again, data security and confidentiality are paramount, especially when considering using proprietary cloud-based solutions for code generation. You don't want sensitive code leaking.
Good point.
Yeah.
And helping UKO staff keep up with the pace of change, like new research or emerging trends in the maritime world.
That's where AI-powered research and horizon scanning comes in. Building on the tools they've already experimented with, like Copilot and Gemini, LLMs can help automate the monitoring of diverse sources, academic journals, industry news, policy papers.
Sifting through the noise.
Pretty much. Summarizing research papers, extracting key trends, identifying experts in niche fields, and potentially even detecting early warning signals of disruptive technologies relevant to hydrography or maritime safety.
But with a caveat, presumably LLMs aren't always accurate.
Absolutely. You always need human review because of the inherent risks of inaccuracy or bias in LLM outputs. They're assistants, not oracles.
Finally, using AI to help with communication, both internally and externally.
AI-generated content. For internal communications, maybe drafting initial versions of training materials or helping with public engagement content.
But that sounds risky, using AI to talk to the public or staff.
It has to follow strict UK government guidelines, of course. The source is very clear on this.
Yep.
LLMs can draft initial content, summarize long documents, help ensure consistency in messaging, assist in developing materials.
But humans finalize and approve.
Always. Human oversight is absolutely critical to ensure accuracy, the right tone, and adherence to strict government standards and public trust principles. No AI gets the final say on official communications.
Okay, so we've explored the strategic why and the wide-ranging what. Now let's get into the nitty-gritty of the how, the implementation strategy, and the technology decisions involved. How are they actually planning to do this?
The document outlines a very sensible phased approach. It's not a big bang. Phase 1 is focused on experimentation and proofs of concept, kicking the tires, basically.
Learning and validating.
Exactly. Phase 2 is about scaling the initiatives that prove successful from Phase 1. And Phase 3 is the long-term goal, embedding LLMs into core processes, making them a standard part of how the UKHO operates day to day.
So it's framed as a journey, not just a single project rollout.
Precisely. And Phase 1 is crucial for evaluating different technologies, building necessary skills internally, and validating that specific use cases actually deliver tangible value before they scale up.
And when it comes to the technology itself, the LLMs, what kinds of models are they looking at? Are they building their own? Using commercial ones?
The strategic choices involve evaluating open source models, things like Mistral or Llama that are publicly available,
Right.
versus proprietary solutions, the big names like GPT-4, Gemini, Claude.
The ones most people have heard of.
Yeah, and recognizing that a hybrid approach is probably the most likely path forward for them, using a mix.
What are the key trade-offs they have to consider between open source and proprietary? Why not just pick one?
Well, open source models offer greater control and customization. You can really tinker under the hood, potentially lower licensing costs too. But
There's always a but.
they require significant in-house expertise to deploy, manage, fine-tune, and really get the most out of them. The document gives an example of how they might fine-tune an open source model specifically on historical notices to mariners for a unique UKHO task. That needs skills.
Okay. And the proprietary ones.
Proprietary solutions, on the other hand, often offer higher out-of-the-box performance, better vendor support, they're generally easier to use, and scalability is often built in. But
Another but.
you have less control, potential vendor lock-in, limited customization compared to training your own, and, critically for the UKHO, significant data security and sovereignty concerns, especially when handling sensitive defense and national security data. Sending that data to a third-party cloud,
Yeah.
that needs careful thought.
So the hybrid approach seems necessary to balance those factors. Get the best of both worlds.
Exactly. It allows them to leverage the strengths of both while mitigating the weaknesses. The document lists key criteria for making these choices on a case-by-case basis: performance for the specific task, overall cost, security posture, the expertise required to manage it, ease of integration with existing systems, speed of deployment, and of course, minimizing that vendor lock-in risk.
And they'll need to keep revisiting that framework as the tech changes so fast.
Constantly. It's not a one-time decision.
And a generic, off-the-shelf LLM probably isn't going to understand the nuances of hydrographic data or nautical charts, is it? It needs specific training.
Precisely. That's a key point. Fine-tuning and customizing LLMs with UKO-specific data is absolutely crucial. A general model doesn't inherently understand maritime charts, survey logs, the complex language of safety regulations, or historical hydrographic terms.
It lacks the domain expertise.
Totally. They need to be trained on the UKHO's unique hydrographic, cartographic, and safety data to make them truly effective for these specialized tasks.
How do they do that? Is it difficult?
There are techniques. Full fine-tuning involves retraining large parts of the model, which can be very resource-intensive, computationally expensive. But there are also more agile methods, like parameter-efficient fine-tuning, often called PEF.
PEF.
Yeah, with specific methods like LoRa. These are more cost-effective and allow for more agile adaptation of models to specific tasks without retraining everything. It makes customization more feasible.
Okay. All of this processing, training, fine-tuning, it sounds like it requires serious computing power and infrastructure. This isn't running on a standard desktop.
It absolutely does. Computational resources are essential. You need powerful GPUs, maybe TPUs, or very capable CPUs, depending on the model and whether you're training or just running inference. LLM work is computationally intensive.
And storage. They have massive data.
Storage needs to be high performance, scalable to handle massive data sets, and critically secure, especially with the sensitivity involved.
And managing all these models once they're built.
That's where MLOps platforms come in, machine learning operations. These are vital for managing the entire life cycle of these models, monitoring their performance in production, versioning different models as they're updated, deploying updates smoothly without disrupting services. It's the operational backbone.
Now, the decision about using cloud infrastructure versus keeping everything on-premise, that must be a huge consideration for an organization like the UKHO, given the sensitivity of their data, especially the defense stuff.
It's a critical decision point, yes.
Yeah.
Cloud services offer fantastic scalability and flexibility, which is very attractive for handling variable loads and large data sets. But
security concerns again.
exactly. For data related to national security or critical infrastructure, the security and compliance concerns with using third-party public clouds are paramount. Data sovereignty is a big issue.
So on-premise gives more control.
On-premise infrastructure gives maximum control over security and data location, but it requires significant upfront investment in hardware and ongoing management effort and cost. It's less flexible.
So it's a balancing act, probably depending on the specific data and application.
Most likely. The balance here is heavily influenced by security requirements, compliance mandates, and the specific sensitivity of the data being processed. It might be a mix.
And connecting these new LLM capabilities into all the existing systems they already rely on, their databases, their mapping tools.
Seamless integration with existing UKHO systems is crucial for success. You can't just have LLMs sitting in a silo. They need to talk to the core databases, the analytical platforms, specific initiatives like the UK Center for Seabed Mapping, and their various defense and national security systems.
That sounds complicated.
It is. The challenges involve ensuring data consistency across systems, keeping data synchronized correctly, and maintaining robust security standards across these integrated platforms. MLOps tools help manage the complexity of these dependencies and the flow of data.
Okay, so we've covered the immense potential and the planned path forward. But as with any powerful new technology, especially in a safety and security critical domain like maritime operations, there are inherent risks. Let's talk about the caveats. What could go wrong?
The document is commendably clear-eyed about the challenges. It doesn't shy away from the risks. Data quality and availability are foundational issues. If the training data is poor, incomplete, or biased, the LLM performance will suffer. Garbage in, garbage out.
And LLMs can amplify bias.
They can actually amplify biases present in the training data. That's a serious concern.
Yeah.
Then, model accuracy and reliability are paramount. You need to trust the output.
And the hallucination problem.
Exactly. Hallucinations, where an LLM generates incorrect but plausible-sounding information, pose a severe risk for safety of life at sea if that faulty information were to be used in critical decision-making, like navigating a ship or planning a rescue.
Yeah, plausible but wrong is dangerous. Bias was mentioned earlier, but the document highlights it as a distinct risk, separate from general data quality.
Yes, because it's insidious. LLMs can perpetuate biases present in historical data. For instance, if past survey planning or resource allocation decisions embedded subtle biases, training an LLM purely on that historical data could inadvertently reflect and even recommend those biases in future suggestions.
So you need active strategies to fight that.
Proactive mitigation strategies are essential. You can't just hope it doesn't happen.
Data security must be right near the top of the list of risks.
Absolutely. Data privacy, security, and sensitivity are critical concerns. Handling national security data, commercially sensitive hydrographic data, maybe personal data, it requires stringent protection measures. Managing the risks associated with third-party providers, especially for proprietary models or cloud services, is a major ongoing consideration.
What about the people who will actually use these tools day to day? The hydrographers, the analysts?
Usability and skill requirements are challenges. Users need training in effective prompt engineering, knowing how to ask the right questions to get useful answers. And crucially, they need to develop the skills to critically validate the outputs from the LLM, not just blindly accept them.
So, building critical thinking skills around AI.
Yes. And of course, the cost and resource intensity, the ongoing cost of infrastructure, the compute power, the security measures, and attracting and retaining skilled personnel all need realistic budgeting and long-term planning. It's not cheap.
Integration is also listed as a challenge, even though it's part of the how. Why list it twice?
Because it's both a requirement for success and a significant hurdle to overcome. Achieving that seamless integration is hard work.
Okay. And then there's a potential paradox: over-reliance and lack of trust.
Yeah, it's interesting. Users might place too much trust in an LLM's output without sufficient validation, leading to errors. Or, conversely, a lack of trust due to past errors or the black box nature of some models where you can't see the reasoning could hinder adoption even when the tool is useful. Finding that right balance of trust and skepticism is key.
And if something does go wrong because an LLM was used in the process, who's responsible?
Accountability is vital. Clear lines of accountability are needed if an LLM-assisted process leads to an error or incident. Who is responsible? The human user, the model developer, the data provider. This reinforces again why human oversight is so crucial in the loop.
Right. And one last challenge mentioned.
The geospatial and temporal complexity of maritime data itself. LLMs aren't naturally built to understand complex spatial relationships like proximity on a chart or the critical importance of time in maritime data. Think tides, currents, changing weather.
They think in words, not necessarily maps or timelines.
Generally, yes, which necessitates the hybrid approaches we discussed, combining LLMs with traditional geospatial information systems, GIS, and other analytical tools that do understand space and time natively.
Okay. Given those very real risks, especially in a safety-critical environment like the UKHO operates in, how do they plan to address them and build trust? What's the responsible path outlined in the document?
The document makes it very clear that responsible AI is not an add-on, not an afterthought. It's a foundational pillar of their entire strategy. It builds on the UKHO's existing strong commitment to data ethics and established principles like safety, security, objectivity, transparency, and integrity.
What specific ethical areas are they focusing on when it comes to applying LLMs?
Key areas include ensuring transparency where possible in how LLMs reach their conclusions. Striving for explainability, often called XAI, so users can understand why a decision was suggested or information presented. Ensuring fairness and equity through proactive bias mitigation strategies.
We talked about bias detection.
Yes. Establishing clear accountability with defined human oversight roles. Guaranteeing robust security and safety measures to protect against misuse or manipulation. Upholding strict privacy and confidentiality standards for sensitive data, and importantly, engaging actively with stakeholders, mariners, partners, the public, to build trust and gather diverse perspectives on ethical use.
And they have to navigate complex regulations here like GDPR.
Absolutely, and compliance is non-negotiable. This means adhering strictly to UK data protection regulations, including UK GDPR and the Data Protection Act 2018, as well as specific Ministry of Defense (MOD) policies that apply to them.
What does that mean in practice for LLMs?
It means applying core data protection principles like having a lawful basis for processing any personal data, upholding data subject rights like access or correction, conducting data protection impact assessments, DPIAs, for any high-risk processing involving LLMs, rigorously protecting sensitive hydrographic and national security information, and carefully managing the data protection risks associated with using third-party providers or cloud services. The role of their data protection officer is critical here.
How do they plan to proactively manage specific risks, like the potential for those dangerous hallucinations?
Through robust risk management strategies outlined in the plan. This includes implementing things like robust feedback mechanisms where users can easily report issues or incorrect outputs they encounter.
So users can flag problems easily.
Yes, and using that feedback for iterative model refinement and retraining, making the models better over time. They also plan proactive monitoring and anomaly detection systems to spot when models might be behaving unexpectedly or generating statistically weird outputs.
Like an early warning system.
Kind of. using techniques like adversarial testing and red teaming, deliberately trying to break the systems in testing environments to find vulnerabilities before deployment. It's about security by design and having clear governance processes for how model updates are tested, approved, and deployed.
And the most important part.
And, most importantly, ensuring that human-in-the-loop HITL oversight is built into critical processes.
Human in the loop, we've touched on it a few times, but why is that specifically so critical for the UKHO, according to the source?
It is the core safeguard, really. Humans are essential for applying complex judgment calls that LLMs simply can't make, for exercising ethical reasoning in nuanced situations where the right answer isn't just data-driven, and for spotting subtle errors, inaccuracies, or biases that an automated system might easily miss.
So the human brings context and judgment.
Context, judgment, ethical grounding, and ultimate accountability. HITL ensures accountability because there's always a human making the final decision or validating the output, especially in safety-critical applications like finalizing a nautical chart or disseminating urgent maritime safety information.
And specific practices for responsible AI.
Yes, things like bias detection and mitigation involve actively engaging diverse stakeholders, hydrographers, mariners, data scientists, ethicists, to help identify potential sources of bias, using technical methods to try and debias datasets before training, and critically relying on that human oversight during testing and operation to catch subtle biases in the outputs that automated checks might miss.
Okay. So they've got the plans, the use cases, the risk management. How will the UKHO actually know if all this investment and effort is working? How do they measure success along this journey?
That's a great question. Continuous monitoring and evaluation are key components outlined. They need defined key performance indicators or KPIs to track progress.
Like measuring how much faster a task gets done. Is it all about speed?
Efficiency gains are definitely one KPI. This could be measured by reduced processing time for things like chart updates, or identifying tasks that incorporate automation leading to a measurable reduction in manual steps.
But a qualifier.
The document stresses this must never come at the expense of accuracy or safety. Faster is only good if it's also correct and safe.
Right. Faster but wrong is worse than useless in their domain. What about the quality side then?
Effectiveness improvements are another key area for KPIs. This could be things like enhanced data accuracy resulting from AI-assisted validation processes, demonstrably higher quality of insights generated for decision makers, or improved decision support metrics for staff using the tools.
How do you measure enhanced accuracy or quality of insight? That sounds tricky.
It is tricky. It involves metrics like factual correctness checks for LLM outputs against known ground truths, assessing data completeness, although defining and measuring completeness for complex maritime data, and establishing that definitive ground truth can be challenging in itself. It requires careful methodology.
Okay. And tracking the impact on what they actually deliver to users.
Yes, tracking innovation. Measuring how many new products, services, or enhanced capabilities are directly enabled by the use of LLMs. This could be things like offering new types of customized thematic charts based on user queries, or developing novel interactive data systems for exploring maritime information.
And ultimately, how the users feel about it all, the people using the charts or the systems.
User satisfaction is a key metric, absolutely. Gauging user satisfaction through established measures like CSAT scores, customer satisfaction, or Net Promoter Scores, are the internal staff finding these tools helpful, trustworthy, and easy to integrate into their workflow. Are external users like mariners or defense partners seeing value?
And how do they integrate feedback from all those different users? It must be varied.
Feedback loops are presented as critical for continuous improvement. It's not a one-way street. Who provides the feedback? It's a wide range. Internal users, defense partners, commercial customers, the general public using their data, international collaborators.
How do they collect it all?
Through various channels, targeted surveys, user workshops, perhaps embedded feedback tools within the applications themselves, formal consultations on new services.
And crucially, how is that feedback actually used? Does it just go into a report?
No, the plan emphasizes using it actively to identify issues and bugs, obviously, but also to inform the next steps in the iterative development process, what features to prioritize, what needs refinement, to improve the models directly by using specific feedback examples as test cases for retraining or fine-tuning, and importantly, to build trust through transparent communication back to users about how their feedback is being considered and acted upon.
So that iterative, agile approach is key for feedback.
Adopting an iterative, agile approach to development is essential to integrate this feedback rapidly and effectively. It's a cycle of build, Measure, learn, repeat.
Looking further ahead now, the document talks quite a bit about building an AI-ready culture. What does that actually involve for an organization like the UKHO? It sounds like more than just technology.
Oh, it's much more than just the tech. It's about integrating LLMs and AI thinking into the organizational DNA, making it part of business as usual, not some exotic special project.
What does that look like practically?
It requires identifying the critical skills needed across the organization. And it's not just needing more data scientists, although they're important. It's about basic AI literacy for everyone, so they understand the potential and limitations. Specific prompt engineering skills for users interacting with LLMs. Crucial LLM validation skills, knowing how to check the outputs. And specialist MLOs, expertise to manage the systems.
So attracting and training people must be a huge part of building that culture.
Huge. Strategies for talent attraction and retention are vital. The UKHO can highlight the meaningful nature of their work contributing to global safety, security, environmental sustainability. That's a powerful draw. They need to show commitment to innovation, provide a competitive environment, and clear career progression for AI specialists.
And upskilling the existing workforce.
Training and upskilling are essential. This means foundational AI literacy programs for the entire workforce, specific training on using LLMs safely and effectively, practical hands-on exercises, and using UK OSHA-specific case studies to make it relevant. This training has to be integrated with their broader talent management and development strategy.
And making sure different teams, the tech folks and the maritime experts work together effectively, that seems crucial.
Fostering collaboration, knowledge sharing, and building communities of practice are absolutely essential. You said tackling complex AI technology effectively requires bridging domain expertise. The hydrographers, the cartographers, the mariners with AI skills, the data scientists, the software engineers, the MLOps engineers, they need to speak the same language or learn to.
How do you make that happen?
Collaboration improves problem solving, leads to better, more grounded solutions, and enhances decision-making. Leadership support is key to encourage this cross-functional work, and providing the right technology platforms for sharing knowledge and collaborating on projects helps enable it.
And allowing for some experimentation, maybe things that don't pan out. Is there room for failure?
Yes, encouraging responsible innovation and calculated risk-taking is important. The document talks about a fail-fast, learn-fast approach. This is crucial for driving innovation, especially with rapidly evolving tech like AI.
But failing fast in maritime safety sounds risky.
It has to be conducted within clear ethical and operational boundaries. You don't fail fast with live navigation data. But you can experiment in sandbox environments. It requires supportive leadership that understands innovation involves some dead ends, and creating those safe environments, often called sandboxes, for experimentation without jeopardizing core operations. Beyond the internal culture, they also need to continuously look outside the organization, which brings in horizon scanning.
Right. Keeping an eye on the future of AI because it changes so quickly.
Exactly. It needs to be a continuous process of identifying emerging LLM technologies, broader AI trends, new tools, and best practices being developed globally. This is essential to stay ahead, maintain their strategic advantage, and avoid investing heavily in tech that might soon be obsolete.
How do they do that?
It involves dedicated research, actively engaging with external experts in academia and industry, attending conferences, participating in cross-government AI groups, and then formulating actionable plans based on their findings. What should we investigate next? What poses a threat? What's an opportunity?
And building overall resilience and adaptability as an organization. Is that part of the AI readiness?
That's essential in such a rapidly evolving technological landscape. It's not just about adopting today's AI, but being ready for tomorrow's. The document suggests this builds on the UKHO's existing foundations, like the flexible design of the relatively new headquarters, which facilitates more agile ways of working.
What does that resilience involve?
It means fostering a culture of continuous learning across the workforce, investing proactively in the skills needed not just now, but for the future, developing strong strategic foresight capabilities to anticipate changes rather than just react to them, and using those sandbox environments effectively for experimentation with future technologies, even before they're fully mature.
So, looking beyond just the LLMs we have today, what kind of future tech are they thinking about?
Yes, thinking ahead. The document touches on possibilities like using AI for scientific discovery, maybe accelerating insights from oceanographic data, potentially even concepts like self-driving labs adapted to hydrography, or integrating AI more deeply with embodied systems and robotics, like the autonomous survey vessels they're already exploring.
And even further out.
and even keeping an eye on potentially disruptive technologies, like the long-term impact of quantum computing on data processing or cryptography, which could affect secure communications. Ultimately, all of this planning, this focus on culture, on skills, on horizon scanning, it reinforces the long-term vision presented in the document. Moving towards things like hyper-automated data lifecycles, from sensor to product, with minimal friction, enabling cognitive data ingestion and processing, where systems understand the meaning and context of data more deeply, using AI to drive truly enhanced maritime intelligence, and positioning the UKHO not just as a user of AI, but potentially as a leader in shaping global AI standards specifically for hydrography and navigation.
An AI leading UKHO.
An AI leading UKHO. The vision suggests strengthens national security, boosts the blue economy, and enhances international collaboration significantly. It's an ambitious vision.
Wow. Okay. This has been a really comprehensive deep dive. We've definitely explored those compelling strategic drivers behind the UKHO's interest in LLMs, really understanding the why this is crucial for their core mission of maritime safety, security, and sustainability.
Yeah, and we've looked at that incredibly wide range of potential applications, the what. Everything from their core hydrographic work and chart production, right through to enhancing maritime safety alerts, national security intelligence analysis, and even environmental protection efforts.
And we've unpacked the practicalities of the how implementing this, including the strategic choices they face regarding different types of models, open source versus proprietary, the hybrid path, the essential infrastructure, needed compute, storage, MLOps, and that vital requirement to tailor these models using their unique maritime data through fine-tuning.
Then we tackled the critical challenges and risks, head-on the caveats. Those inherent complexities of LLMs, like hallucinations and bias, which are amplified in such a high-stakes domain where errors have serious consequences.
And crucially, we've seen how their strategy emphasizes a responsible and ethical path forward. That's not an afterthought. Bias detection, strict regulatory compliance, robust risk management strategies, and that non-negotiable pillar of human-in-the-loop oversight.
So the key takeaway here for you listening is that LLMs offer immense potential to enhance the UKHO's vital mission. It's really significant, but success isn't about blindly adopting the latest shiny tech. It hinges entirely on a strategic, pragmatic, responsible, and continuously adaptive approach.
And it really shows, doesn't it, how these complex technologies are being applied in unexpected, incredibly vital public service roles, fundamentally transforming how we understand and navigate the world's oceans.
It absolutely does. And it highlights that careful, critical balance needed between driving innovation and ensuring responsibility, especially in areas where the consequences of error are just so significant.
So here's something for you to maybe mull over after this deep dive.
Well,
Consider the document's long-term vision of hyper-automated data lifecycles and cognitive data processing at the UKO. What could it truly mean for understanding the ocean in ways we've never before imagined? And maybe, what new questions might that raise for all of us regarding data ownership, privacy, and our trust in automated systems that literally guide us through the physical world?
Or perhaps think about the UKHO's potential role in shaping global AI standards for navigation and hydrography. If they successfully integrate AI responsibly and effectively, their approach could become a model internationally. How does that significant potential leadership responsibility change the way they must think about adopting these powerful new tools today? Food for thought.